Okay, today we're going to talk about exponential logarithmic functions, all right? This is kind of a review of those topics, all right? Properties of exponents, we'll start with those. All right, when you multiply, all right, you're going to, you multiply like bases. So let's say I have x to the a times x to the b, all right? And that's going to equal x to the a plus b. You add the exponents when you are multiplying like bases, all right? And when you're dividing like bases, you know, it's like x to the b, x to the a over x to the b. That is going to equal x to the a minus b, right? That's the property for where you divide. When you have fractional exponents, all right, fractional exponents can be switched back and forth to radical form, okay? So like if I have, for example, x to the, well, I'll do a over b first, right? I'll do it kind of general. A over b. The root of a tree is on the bottom. So the root is the one that's on the bottom of the fraction. So it's the bth root of x and then raised to the 8th power. All right? Oops, that's an a. Okay, like that. All right? Okay, so that's how you take a fractional exponent and turn it into a radical form. Okay, negative exponents, they need to be sent on vacation, right? It's like the reciprocal. So like if I have x to the negative a, that equals 1 over x to the a. All right, just be careful with this now. Don't kind of break up families when you do it. Like if I have like x to the negative 1 plus 1 over x minus 1, I think this is one of the practice questions we did. That x to the negative 1 can't go all the way down to the denominator here. That's really just going to be 1 over x plus 1 all over x minus 1 like that. Okay? And then you would go from there. Okay? It just switches that part right there. Now, if you have a negative exponent, it always doesn't always send things to the denominator either. Like if I have a negative exponent in a denominator, then that sends it to the numerator and makes it positive. All right? Just like that. 0. All right? 0. All right, if I have anything to the 0 power, x to the 0, no matter what x is, it equals 1. So if I have 3x to the 0, that equals 1. If I have 3x to the 0 like that, that is 3 times 1, or 3. So be careful of that difference there. All right, exponent. This is basically like power of a power. So like if I have like x to the a to the b, that's going to equal x to the a times b. All right, that's what I do with that. So like for an example for this one, let's add an example. Let's take like 2x squared y and raise that to the 3rd. All right, and basically I need to distribute that exponent. All right, that was x squared, so that's going to be x to the 6th, y to the 3rd, 8x to the 6th, y to the 3rd. And that's binomial expansion where you see a lot of that, right? Okay, and then we've got some examples, and the examples unfortunately are all kind of jacked up a little bit here. So I'm going to fix those, and once I fix those, I'll unpause the video and continue. Okay. Then just a word of warning here, right? You're probably not going to have room to do this right on your sheet, so you may want a separate sheet of paper if you're going to kind of follow along with these examples. All right, basically what I want to do with these kind of questions here, where I have exponents, is I kind of want to get the weirdest looking thing alone. I want to isolate the exponent here if I can. So I'm going to have x cubed. By adding 7 to both sides, I get x cubed equals 21. Now, what I do with this kind of instance is I raise both sides to the reciprocal power. And then I use my power of a power rule. 3 times 1/3 is 1. It's x to the 1st. I get x. All right. And then now that is the cube root of 21. The cube root of 21. Now 21 is not a perfect cube. Okay. So if it wants it to the nearest 10th or anything like that, then you would use this. All right. I could do 21 raised to the, and then if yours doesn't raise it up like this, but instead gives you the caret with a parenthesis, give you the caret, you need to make sure you put the parenthesis in, because it's going to do the power before it does the exponent. All right, 21, oh, sorry, it is 21 raised to the 1/3. And if you have it where it keeps it all up in the exponent, you don't need the parentheses. Okay, and if it went to the nearest, say, 10th, it'd be 2.8. All right, 2.8. All right, what do we got here? X to the 3/2 plus 5 equals 9. All right, so what I'm going to do is I'm going to subtract 5 from both sides. All right, so I get x to the 3/2 equals 4. And then I raise both sides to the reciprocal power to the 2/3. Or to the 2/3. All right, just like that. And I get x equals 4 to the 2/3. Which again, unfortunately, this doesn't come out evenly. I should have picked some of these that come out even, I guess. But we can just do it on the calculator. 4 raised to the parentheses 2 divide 3. I'm kind of in the habit of using the parentheses, even though I don't have to now with the new operating system. So it's 2.5. All right, there we go. 2.5. All right. And the next one, x to the negative second equals 1/16. X to the negative second equals 1/16. So what I need to do is then, if I have this, I raise it to the -1/2, which equals 1/16 to the -1/2 power. Okay, like that. Now, I can take this negative exponent and flip that guy. So that's going to be 16/1 to the 1/2 power. And now this fractional exponent, that's the same thing as the square root of 16, which gives me an answer of 4. Okay? And that is going to be a plus or minus 4. There we go. Okay. Hey, it's plus or minus because we took the square root right here, where I did it to the -1/2 power on both sides. All right, exponential functions. Y equals AB raised to the x. B greater than 1 is a growth, and decay is between 0 and 1. All right, so for like a decimal or a fraction, it's going to be decaying. If I add or subtract percent from 1, depending on growth or decay. So the price of gas is $4.09. If the price is expected to grow 9.5%. All right, so the initial amount here, this is my A. And then this 9.5 is going to give me my B. And since it's growth, it's 1 plus 0.095. So I have 409 times 1 plus 0.095. All right, and it's expected to grow that much per month. How much will it be in 3 months? So then it's raised to the 3. All right, and there we go. And then you can evaluate that. Right, and that's simply 4.09 parenthesis 1.095 raised to the 3rd power. All right, about $5.37. Okay, 5.37. All right, moving on. Exponential equations. Okay, this is where you have the variable exponent. Now get a common base if possible. That is the easiest way to solve an exponential equation. You can solve graphically, where I let y1 equal one side and y2 equal the other side, and show the necessary work, which means like all the table settings and everything else that you use. Or you can use logarithms, which we'll get to on the next page. All right, so this one right here, 125 and 25. Now, those are both powers of a common number, right? 125 is 5 to the 3rd to the -2x, and 25 is 5 squared to the x plus 1. Now, with the properties of exponents that we just covered, it's going to be 5 to the -6x equals 5 to the 2x plus 2. Don't forget to distribute there. Now, once you have like bases, you can drop the bases and set the exponents equal to each other. -6x equals 2x plus 2. I can subtract 2x from both sides, or I can add 6x to both sides and subtract the 2. I get -2 equals 8x. So I am going to get x equals -1/4. Okay, there, solve for x. Solve graphically. Okay, that's where I let y1 equal 4 to the x minus 1, and I let y2 equal 5. Okay, so now I go into my y equals, clear anything out that I already have in there, and I'm going to have 4 raised to the, and use a parenthesis, x minus 1. Okay, and then for y2, I am just simply going to use 5. Now I'm just going to try the standard window setting first to see if I can see an intersection here. And if you do, that's great, fantastic. And then you calculate the intersection, remember, under second trace, which is calc, 5. And then first curve, you want to move the spider kind of close to it. You know, and it doesn't have to be right on top of it, but that's probably close enough, right? Enter, enter, enter. and it'll tell me the intersection, 2.16, comma 5. All right, so x equals 2.16. All right, how do I receive credit for this graphical solution? I need to kind of show some work here. All right, that work includes the picture, the diagram, the graph that I have come up with, right? This I have already called y1, so that's my y1, that's my y2. I need my window settings. This was the standard window, negative 10 to 10, negative 10 to 10, okay? And then I calculated the intersection. I want you to label the intersection. It was 2.16, comma 5, and then you give the answer, x equals 2.16. All right, now a graphic solution, if the directions don't specify an algebraic solution, a graphic solution like this should receive full credit, especially if you've included like your window settings and labeled the graphs and the intersection. Okay. I think what we're going to do is I'm going to do a second video for logs because I'm kind of running short on time and I don't want to rush through logs too much. Okay, so exponential functions, we're going to leave solving exponentials with logarithms to the next video. Okay, so please watch that one as well. All right, and that will be what you use to complete the back of this note sheet. Okay, thanks.